So I'd like to welcome you to our workshop that is organized by the Desire and WaterDrive projects, both projects from Interreg Baltic Sea region. And thanks a lot for the team of WaterDrive for the support in organizing this event today. So we will start with this short impulse talks of mainly people cooperating in the Desire project, but there will also be one talk about from Frank Bondgard from the WaterDrive project. The main questions and main discussion should be postponed to the breakout groups that we will have later. But you can ask questions for understanding also directly after these talks. And I will start with my presentation about the Desire project, potential effects of peatland rewetting and palodiculture and water quality. Desire, the long name of Desire is development of sustainable peatland management by restoration and palodiculture for nutrient retention in the Neiman River catchment. And the main idea behind it is to reduce nutrient loads to Neiman River and the Baltic Sea by peatland restoration and implementation of palodiculture. And the means are research and practical investigations, stakeholder involvement, and exemplarily rewetting of peatland sites. Here's a picture of the catchment area of the Neiman River. I think it's the fifth biggest sub-catchment of the Baltic Sea. And there's a large input of nutrients, first to the Coronian Lagoon and then to the open Baltic Sea. So 134 tons of phosphorus and 4,876 tons of nitrogen have been loaded to the Coronian Lagoon in 2016 after Oblomka. But coming to the role of peatlands in terms of nutrients, so normally peatlands should be near natural if they are more or less untouched, if they are wet or rewetted, and they function as sinks in the landscape. So they do that by peat formation and biogeochemical processes like carbon and nutrients uptake by plants and fixation in the new peat, phosphorus precipitation and reduction of nitrate to N2. And on the other hand, we have still increasing area of drained peatlands that are rather strongly degraded, and if they are drained, they are functioning as sources for nutrients in the landscape and also for greenhouse gases because of the mineralization of peat and fertilization. So there is a large amount of leaching with drainage water of nitrate, ammonia, potassium, magnesium, dissolved organic carbon, and phosphorus. And we have also wind and water erosion that's mainly important for the phosphorus and carbon losses from the sites. And we have large amounts of greenhouse gas emissions. And the basic assumptions of our projects are that rewetting of peatlands reduces mineralization and emissions for nutrients and greenhouse gases, and that nutrients from inflowing waters and deposition can be eliminated or fixed in the peat. And additionally, the implementation of palodiculture can provide an additional export of nutrients by biomass harvesting. So peatlands should be rewetted in the whole catchment area, and palodiculture should be installed where possible. If we now look, for instance, for for the nitrogen balance in fen peatlands in northern Germany, and compare sedge reed and intensive grassland. The sedge reed with a medium water table of 10 centimeters below ground, and the intensive grassland of in average 50 centimeters below ground. Then we have a sum of inputs in the intensive grassland of 480 kilogram nitrogen per hectare and year, and that leads to a N saldo at the end, because there are also exports by harvest and denitrification. We come up to 200 kilogram nitrogen that can be leached, or that is leached to the open waters, the drainage ditches and so on. And on the other hand, if we look at the sedge reed, there's also some mineralization and deposition, and so we have an N saldo of about 30 kilogram per hectare and year. But if these sedges are harvested once a year, the saldo will even be negative. We elaborated a review on nutrient retention in wetland buffer zones with the Desire project, and the main outcomes were that wetland buffer zones with organic soils remove 53% of the nitrate N, and the variance in load had a stronger influence than the soil type on the N retention in wetland buffer zones. So the picture shows the total average for all kinds of soils that have been evaluated. So there's not a very big difference between mineral and organic soils, and the harvesting of vegetation will minimize the potential phosphorus loss from rewetted wetland buffer zones. Another publication on the effect of harvesting of wet peatlands, mainly done by the clearance project that had been parallel to our project, and that showed that Typha latifolia and Phragmites australis have a great potential for nutrient removal in wetlands, and both species produce high biomass in a wide range of abiotic soil conditions. And there's a substantial carbon sequestration in biomass despite nutrient limitation, and Typha latifolia is more effective for phosphorus and potassium than Phragmites australis. But there's not everything is like it should be. So we have this problem that pay mobilization in rewetted fens may occur, and this risk of pay loss exists if molar iron to phosphorus ratio are lower than 10 in the upper most heavily decomposed soil layers. And how should this be addressed? So in Denmark, they do measurements and examinations, and they exclude all peatlands with an FAP ratio lower than 10 from rewetting. And our approach is to mitigate phosphorus release. The biomass should be harvested as a means for export of nutrients. And there has been elaborated online tool that is available in the internet on our project homepage from clearance, and there you can give in several parameters like area size, soil type, harvest time, nutrient input, and so on. And at first, according to a large database, you can calculate the expected biomass in tons that can be harvested. But more important is today to get information about the nutrient removal potential for plant species, soil types, harvest dates, and other parameters. And in this example, for instance, we have a mean export of nutrients like nitrogen from 127 kilogram per hectare and year, for potassium 60 kilogram, and for phosphorus in the mean 9.6 kilogram that is exported. The recommendations for the development of peatlands in the Neiman catchment for nutrients reduction from my side is to at first protect all intact peatlands and don't drain them at all. Those that are drained should be rewetted and wetland buffer zones, they should function as the wetland buffer zones in the landscape, and sites with highest removal potential for nitrogen and phosphorus should be identified. And the sink function should increase by combination of rewetting and paludiculture activities. So by that, the mineralization of peat is stopped, the greenhouse gas emissions can be minimized, and the nutrient loads can be removed by more than, or eliminated by more than 50%. So peatlands rewetting and implementation of paludiculture should urgently be considered with river basin management plans and with special planning and all kinds of thinking about reduction of nutrients in open waters, and especially also in the Neiman River catchment area. The proposals for the topics to be addressed in breakout groups in my group I mentioned here, but we can come later to this at the beginning of the breakout group. And so like this, a polder could look like if it is managed for paludiculture. Thank you very much for your attention, and yeah, if there is a question of understanding, please come with this now, and all other discussion we should postpone to the breakout groups. Thank you very much. So if there is not any question, we would come directly to Mateusz Gregorek and Marta Stachowicz on hydrology and ecology of peatland rewetting. So please, I stop sharing.
Good morning. Hello guys, can you hear me?
Yes.
Very good. So I am now pressing the button which says to me that this will stop other screen sharing. Do you want to continue? Yes. So I will try to do it. Okay, and then I try to share my screen. And now please tell me if you can see the full slide. That should be here. Can you see this?
No, it's not
a presentation. Yes, this is perfect.
Yeah. Okay, so again, hello and welcome to our seminar today. I will try to present you a very up-to-date topic of hydrology and ecology of peatland rewetting. At the same time, I'm a bit stressed because I see a lot of names here who are experts in this field. That's why I must select some things that will be also interesting to all of you who already spend a lot of your life on rewetting and this type of issues. So I will focus more on our results we gained in the Desire project. So we'll be talking about the processes we measured and what came out of our research. So as we all see, rewetting tends to be a wise management of peatlands in most of cases where we can afford doing this. And our opinion is that we should do it everywhere where possible and every time when possible. Then this is a nice picture from Norway, from one of the rewetting projects I'm directly involved in. So this rewetting starts to be a regular measure. So from rewetting, we get nice sites like this one, which was rewetted in association with the Desire project in Lithuania. We get more water in landscape, so we got more benefits which are associated with well or better functioning peatlands. What is a pity is that we are not getting those peatlands restored. So what was recently published in the paper of Jürgen Kreiling and colleagues in Nature Communications, it shows that rewetting of fence, in this case mineral traffic peatlands, does not make them natural. So here we can see the difference between those red, which are rewetted, and blue dots, which are natural. So those parameters like this NMDS or like vegetation for hydrology, for geochemistry, and for land cover characteristics, they tend to overlap in a part, but in general we are not getting what we intend to get. And this is really nice paper. So it shows us that maybe biodiversity in the short term is not necessarily our goal of rewetting. But of course, this does not mean that the rewetting should not be done. And showing you two examples why we tend to think that it is still worth of doing this rewetting and getting more than just thinking about biodiversity. Amalva, that's one of our desired research sites, strongly modified peatland, strongly drained, water levels very, very deep. We did there some extensive field measurements, and our network is still there. From our experience, from the modeling perspective, it comes out that if we do the most we can, so if we increase water tables in those ditches aside of this rectangular field, then we are getting some increase of water levels. You can see here what we could expect. In the close vicinity of the ditch, we get like 40-45 centimeters of increase of water level in this particular day. In some other places, so the farther we get from this blocked ditches, then the result is smaller, but still the area is considerably wetter. What shows also off nicely in our indicators that we quantify here, so we can see that overall annual increase of water levels within the site is expected to be as high as 0.15 meters or 15 centimeters. Some people can say that it is not much, but still when we are considering the whole year and this annual basis, this 15 centimeters seems a lot. On the other hand, we have the other research site, which is Gromowo Peatland. That's not the famous Gromowo, which is on the other side of the road. That's the fluvio-genius mire, which is located in the Neiman Delta. It's a bit problematic because our project, Have a Look, is oriented at Neiman Basin, and our Gromowo Peatland is located a little bit beyond, but this is still Neiman Delta, so we say, okay, this is here. We spent some time in finding appropriate spot for monitoring in Neiman Basin here in Kaliningrad region. So we found that this is a very interesting site. It's so interesting to us because it used to be reclaimed, it used to be drained peatland. Nowadays, you can still see some of the remnants of this old drainage system. But if we have a look at the data, then we realize that our Gromowo peatland is considerably wetter. Of course, this is a completely different system. It has been drained 100 years ago. Then, since then, it was not that much used in any agricultural purposes. So what we are documenting, in fact, it's spontaneous restoration of the peatland, of this fluvio-genius mire in the valley of Neiman, close by to the edge of the plateau. And here you can see comparison of distributions of water levels. So for instance, in Amalvas, we have for only, let's say, 25% of year, we have inundation, whilst in Gromowo, in this site, of course, this is completely different peatland, but still we can see that it's much wetter. And this is the result of spontaneous restoration of this site. What we did here, so we did the modeling the other way around. So we used our data just to see what might happen if we drain this peatland once again, or when we implement the actions which are planned for restoration of agriculture, of wet grassland agriculture in this area. So have a look before and after. This is the distribution of water levels now. And if we do the drainage, then we will get serious decline in water levels. So we will just remove water from the landscape. What is important and what can we compare this to? This is a paper of Piotr Banaszuk and Andrzej Kamocki from Narew Valley, which is similar in a way to Gromowo peatland we've been monitoring. So have a look here at this graph. This dotted and dashed lines, they represent water levels in 70s, 80s, 90s, and the years of 2000. Have a look, the steep and continuous decline of water levels between particular seasons. And nowadays, this blue dashed lines shows us Gromowo. So what happens in Gromowo? So when we are searching for reference, when we are searching for proofs, then voila, we have it. We have Gromowo. We have this Virginius Meyer that not well maintained for agriculture for the last century, reclaimed itself in terms of water levels and hydrological stability. So what we see also that rewetting starts to be a regular measure. Still, it remains an action that is implemented by hobbyists. So allow me to say this. So it's not a national strategy for wise management of peatlands in most of cases. So what we observed in our project that we need indicators or we need tools that can allow people or stakeholders just to know what will they gain from rewetting. And we also address this drivers like European Commission's suggestions for most of the countries, but this is for Poland, what Poland should do for efficient implementation of common agricultural policy. And it's written here that in general, we must increase stock of carbon in our soils. And we developed a tool which is now still in the beta mode, but it's called SurveyPeat. This is one of the main projects of our Action in the Desire project. So that's a tool that allows us to quantify co-benefits associated with peatland rewetting. So if you are a person or a hobbyist who has a field, a meadow with a ditch, and you intend to block this ditch, then you can use this tool in order to get some output, what you would potentially gain if you rewetted this object. So here I just show you some steps. We developed this tool in order to work in simplified mode. So for people who are not necessarily soil specialists, and in comprehensive mode where you can specify everything. Then you can select condition of your ditch. So how deep is your ditch? Then you can select hydrological type of your peatland. Then you can you should specify how many ditches are there in the system. So we have two options: either there is just one ditch or two and more ditches, because we use some different calculation scenarios. Then we specify land use, depth of water in the ditch, some parameters of the pit, spacing of ditches, and we get a final output. Of course, it's still a kind of an approximate result. But have a look, if you are interested in implementing a live project or something like that, then you get this type of fact sheet that by rewetting your peatland, you are gaining more than 1,000 cubic meters of water, let's say per annum. Then you get a carbon storage at the level of 106 tons. That prevents emissions from this peatland. Then you also get a balance of nutrients and some phosphorus flush that comes out when you rewet this peatland. What is more important, we also quantify the average value of ecosystem services you get through this rewetting. So if you are wishing to spend your money on rewetting, you can compare this money to this ecosystem services, and you can say that by multiplying this value in years, then you say that it's not spending, it's not an expenditure, you're rewetting, but it's just an investment. What is important for the final user is that you get an information how many ditch blocks you should construct. And I understand this is not intuitive, you get 1.13, but it all depends on the slope of your ditch and the number of ditch blocks you must construct along your ditch in order to increase water level to the desired level. And this is the damming case. So this information are helping the final user to specify what should be done when you intend to rewet. So to conclude with, I had no idea how to sum it up, but I just wanted to say that in the beginning of the 20th century, there was a guy whose name was Jean-Marc Cotet, and he was doing some drawings how the world in 2000 will look like. So have a look here. Imagine that there is a policeman, the traffic is above the ground, all the people are using little planes, and these people here are looking around what happens, and this policeman is looking after the traffic. So this was his imagination. Not very far from the reality, but still some issues are not solved. In this case, I think that if we are thinking about management of peatlands, this at the moment we consider a kind of action for hobbyists, but I think in the future it will remain universal and applicable measure for wise peatland management. And I hope that our findings here and also the findings of your research as well, guys, will help people to get it done properly. So thank you very much. Thank you, Marta, for cooperation in making this presentation, and we can go forward. Thanks.
Thank you, Mateusz. I think we are nearer to reality than this picture shows, but the Savvy Peat, and I think that's a promising tool for calculating effects of water retention. Are there any questions about? Yeah, Dominic?
I mean,
yeah, Mateusz, many thanks. This was a nice presentation. You was making it mad in the beginning, but you was not doing it mad at all. You know, there's this discussion of this overriding role of water table, and you was showing nicely, yeah, that it is actually changing in space and time, yeah, several decimeters. So what would you say, should we stop, recommend any certain water table depth for rewetting of peatlands? And the question which comes out of this one is for your model, which seems to be very interesting also, how you considered this spatial and temporal changes of water table in the model?
Are you asking for a survey peat or for those models,
yeah.
that
Yeah.
for survey peat?
Yeah.
So we spend a lot of time thinking about this, and in fact we are using here a very simple approach. We are using equations that used to be used in the past for peatland drainage. So we use equations that people used to calculate what should be the distance between ditches and what is the initial or what should be the desired depth of water after rewetting. So we know these elements, but what we don't know the initial water level in the peatland. So we try to calculate it. And this means we are calculating this purely in the steady state. So we are attempting to get these average conditions, and we are not considering any special variability or so. Everything will be written in the manual, and the manual starts to be very, very long because there are many assumptions. But we compared this to mud flow studies, and it fits. So it shows that it helps people to quantify this. Of course, I'm not saying that this is the tool you just apply, you get this output, and everything is like that, because there are many uncertainties around. Especially with respect to phosphorus, you know, the type of water which is there, and carbon, but still it allows you to say what is the expected or what kind of benefits you might expect from your rewetting. So we are not getting there any serious groundwater flow modeling. It's just a simplistic two-dimensional approach, which we then extend in the third dimension by multiplying this through the length of the ditch and the length of the ditch.
Mateusz, thank you very much. I think we must go on with the program now and postpone the discussion to the breakout groups. So now we come to Nerjus Zablecki, Jorate Zensikaite, and Amal Zamalkova. And it's about practical rewetting measures and planning and planned land use activities of rewetted sites. So please, it's up to you.
So assume that I start, or Amal, you want to start first? I guess it's only me. Okay, good. I try to share my screen. Okay.
So now I stopped. Huh?
Okay. Good. Okay, so you should see my screen and full mode.
Yeah, that's okay.
Yeah, so I'm Nerjus Zablecki from Lithuanian Fund for Nature, and this presentation is made together with my colleagues, Jorate Zensikaite So we in Lithuania we had in desire few components to do, and one of them was about real rewetting in one of the protected areas of Lithuania. And also another presentation will be given later by another colleague on Peatland database. So it is a bit connected, but I will talk on what we did on the ground. So the site we selected is Žuvintas Biosphere Reserve. That is one of the only one biosphere reserve in Lithuania, and one of the I think 6 Ramsar sites of Lithuania, big wetland complex. And here you see the map in the ground. That's the Peatland database, and you see orange. This is the hotspot for restoration of damaged peatlands. So Žuvintas Biosphere Reserve is in that area. And yes, so why it stopped? I don't know why does it not work. Okay. So another reason to choose Žuvintas Biosphere Reserve was that it is also listed among the peatlands which are suitable for polyculture. As you see, here is Žuvintas. It's 8,000 hectares altogether, and it has different sites in itself, but some quite big part of these sites, of course, some are red because there is a lake, but beside that we have a lot of green areas which are suitable for polyculture, so to say, drained agricultural mainly areas, and which need to be restored, rewetted. And another reason is that why Žuvintas Biosphere Reserve, it's because one of the, as you see, it was in the past, yeah, the traditional usage of biomass of hay in these wet areas, and nowadays the reserve, the people working there, they are looking for new solutions in nowadays context. So it's easy to work with them, and we have quite a good network of farmers who are willing to do, and also municipalities. There are 2 municipalities meeting in that borders in that area, and all of them are looking into supporting such projects and initiatives. So for the restoration, we have chosen 3 areas. One of them already Mateusz talked about is the main area, is a Malvos polder. It's a huge polder of some 200, a bit more than 200 hectares of areas. And beside that, we still had later included 2 other smaller sites which are also drained and need restoration around the lake. So what we did, so we did planning, as it was necessary to do some sort of technical designs and measurements. Then we achieved that for Amalvas polder, which is in the managed actually by the municipality, we forced them to, not forced, but the rules for maintenance, they were frozen for some years, and because of this project we initiated discussion with the municipality, with the farmers, and as a consequence we agreed to renew, to update the rules, how especially on water level regulation, because there is sluices and pumping station which is pumping water, and before it was like water was pumped according to the wishes or phone calls by the farmers. So we came to the discussion, and finally we set up the the water level, which is based on data loggers, so it cannot be lower than some appropriate exact level at altitude, meaning that the water level cannot be lower than 30-40 centimeters below the surface. Of course, it's maybe not enough, but that's first step, and we still have to work on further management of this polder. But in the pictures later, you will see still that some areas are already lower, because polder in itself is not even, and it has the different heights. So it's some complex issue, and some farmers are complaining that they can't enter the area already even in summertime. So there must be some compromise. Then we did bush removal and mulching of stems, installed dams in areas, and so altogether we impacted by around 100 hectares of peatlands. Yes, and so the other two areas which I talked about, overgrown, drained by ditches, and we did a removal of bushes, installed a dam, and yes, and mulched the bush stems of the bushes. And this area in the spring looked like this, rewetted, a lot of birds, so a really nice area. Another area, so they are not big ones, I'm showing you about 20 hectares altogether. And another area was, what was interesting, that farmer himself built that dam. It doesn't look nice, but the fact is that farmers can do installments, and there is no need for expensive, fancy excavators to come to the area. So that's the point, and for others to learn. And the area is now grazed by cattle. So it was completely overgrown by bushes and abandoned for years. Yeah, it looked like this. We do monitoring, vegetation monitoring, and one of the what we found out that mulching of tree stumps, bush stems, is quite a good method to avoid the overgrowth, because normally if you have dense overgrowth by woody vegetation, it's always a problem to get rid of them. They disturb all the hay mowing, grazing also does not help much. And still we have ongoing discussion here in Lithuania, and later on we were trying to find out if there is any good, like best practices recommendations on what to do with the stumps, and actually there is not much about it. So because that's very common, especially in such countries like Lithuania, Poland, Germany, where we have mainly fence, not raised box. Then we monitor water level. So there is a graph, unfortunately data until end of June, but you see that water level was above the surface, and even in the end of the June we had -10 only of water level. This graph is from a Malvas polder on one of the sides of the stripes inside. And greenhouse gas measurements will be done by the Life Baltor project, so they will come later. And another challenge we had to solve, solving still, what to do with the biomass, because biomass is not needed anymore. Hay is, you can see still in Lithuania, all full meadows of grasslands full of hay balers. Nobody is using them. And in Žuvintas, this problem was solved in interesting way that farmer part of this biomass was simply putting on the field and plowing upside down and leaving it. And it seems that this hay, this biomass, old grasses are fermenting in the soil. And I don't know, we did not research how effective this is ongoing, but nevertheless, yeah, this is the way he manages, and a part of it is still used by grazing by another big beef farm. And that's why we thought about doing something else, and we came to the idea to composting, because that's what usually we are being asked by the Ministry of Agriculture. And we, as a result, we came to one of the oldest Lithuanian composting company. Here you see the old aggregate for crashing the biomass. So we made a deal that this company will come to the farmer with this crusher, and we installed a composting place in old fertilizer storage, put their biomass harvested in Amalvas polder. So altogether we put about 20 tons of biomass, and did monitoring, and it was done in August when he started to harvest the biomass. And now we have the results, chemical analysis, and they are promising because even in such short time, normally for composting we need 6 months, and now we have only 5, not full 5 months passed. So we have a pH which is 8.3, 8.4, which is suitable for the application for agricultural cultures, and especially in such fields like in Lithuania, acidic ones, and becoming acidic. And we have a NPK, the same like in normal compost, which company is doing from all these technological knowledge and right components. And there are, of course, some challenges like too old biomass, which does not have enough fresh materials for fermentation. So, but they are still manageable, because even in if farmers are harvesting peatland, wetland biomass up after middle of July, because they according to agro-environmental schemes. So still it is okay, but in late August biomass would be too complicated. And yes, and there is need to put some other mixtures. And that was my last slide. Thanks.
Thank you very much. And am I right that Amal will also give some insight?
Mm-hmm. Yeah, can I? Quite fast. Do we have enough time, Wendelin?
Yeah, but we must hurry a little bit. Yeah.
Yeah. Okay. I would share my screen. Sorry for English speakers. My presentation is in Russian, but if someone would need that, I would send the translation as soon as possible. Thank you for giving me the floor, because for the Kaliningrad region, participation in Desire is a big success. Since 2016, we are in touch as a ministry, and as our state institution, Park Vishtenetsky, we're in touch with Zukov Foundation and Greifswald Institute and University concerning the wetlands management issues. And that's very important for us, because for the Kaliningrad region, because you know, we have the total area of the Kaliningrad region, which is 1.5 million hectares, and 6% of this territory is covered by different wetlands, peatlands and wetlands, no matter, but it's 84,000 hectares. So for us, wetlands management and rewetting is one of an issue also, as for the whole world now. And my presentation is not about rewetting actual, but it's about our plans concerning rewetting, and that first, when we joined this project, for us, of course, desire and all the activities within the desire, for example, rewetting of degraded peatlands and other activities were more about nutrient retention. But you know, Russia is a kind of very unpredictable country, and we spent more than 2 years insisting on this project, explaining to different authorities the need in rewetting of the degraded peatlands in the Kaliningrad region, as in the whole Russia, because the process is going around different regions in the Russian Federation also. Which is a good example for all of us. But we never knew that our project, where we work for the Neiman Delta concerning the nitrogen and phosphorus retention, would also be a carbon retention project. And I also consider it success because it gives us some flexibility in future concerning rewetting of peatlands in the Kaliningrad region. I would not stop on the importance of rewetting, because carbon retention is also about climatic changes, which is a topic for Russia now this year. And the project desire in the Kaliningrad region is mostly about the rewetting of different areas. And concerning biomass use, the biomass that would grow after the rewetting, the same as Nerijus was showing the Lithuanian part. So for us, it's also a topic how to evaluate this biomass, how to speak business language concerning this biomass, and how to use this biomass later. For us, it's also a part of this cross-sectoral dialogue, which is very important, and exchange of knowledge with our partners. After long discussions in the Desire project team, and after the kind of inventarization of the wetlands and peatlands in the Kaliningrad region, with the help of our expert Maxim Naprienko, we made this map. The many areas were discussed, but finally, if you see these 11 and 12 areas, Vishnyovo peatland and Vidgirinsky peatland were chosen as 2 pilot plots. This is Vidgirinsky degraded peatland, which is quite close to the Kaliningrad. It's only 1 hour commuting, and it's 112 hectares. We managed to evaluate social risks for this area. We found all the farm users. We had several meetings with the municipality authorities due to experts that helped us in this social risks evaluation. So it was done quite professionally. And topography and order mapping was done, as well as historical data was collected for the channels and for the hydrological system for this plot. The same was done for Vishnyovo, which is only 34 hectares, but also it was discussed with the municipal authorities in Neimansky area, how we would deal with this area after rewetting, and if rewetting is possible. In comparison with Vidgirinskaya, it's a bit tough because the area located quite close to the railway line, and also gasification line, which is not really good for showing this area to tourists, farmers, and local population. But also we received a written confirmation that this area should be rewetted in coming days. We also discussed polyculture. It's a little bit pity that in Kaliningrad we mostly discuss cranberries, and when we try to explain the interested parties what is polyculture in general and how huge the potential of polyculture for climate issues, for local business, Mostly we discussed here cranberries, and due to our partners from Desire, we had very nice meeting with specialists dealing with such planting of cranberries. One of them was from Holland, and even Kaliningrad Ministry put some information on their side because they consider that it's very prospective. For example, if on the rewetted areas, the cranberry would be grown. So it's also about the changing the land use after the real rewetting. Of course, we speak about the organic farming, and also concerning the carbon farm that is created on Vidgirinsky. It's also, as I said, very unpredictable story. You know, I told already to all our colleagues that in February 2021, our Federal Ministry on Higher Education gave this task to different regions to create carbon farms. These carbon farms, you see, for example, Ugra in Kaluga, they have this kind of glamping showing a carbon farm for students, for scientists, showing, having the design as a molecule of CO2. So it's a kind of story about the monitoring of carbon. It's about investigations for students and for scientific institutions in the Russian Federation. It's a story about the control of the carbon emissions, and also it's about carbon balance. And in our case, it also was a success because we were really insisting on rewetting and explaining all the ministries the kind of advantages of the rewetting itself, economic advantages, biological advantages, agricultural advantages, for example, but we would never know that the climatic advantage would prevail. And it's also quite good for us. And we couldn't imagine even that the Vidgirinskaya, you see this, the plant map produced by Maxim Naprienko. It is a symbol of Vidgirinskaya at the moment. It was decided that Vidgirinskaya, due to it quite a good location, due to possibility to be rewetted quite soon within Desire project. And then some other issues, for example, as historical mapping was saved, and new topography was produced in May. That's why this plot was decided to be a carbon polygon. And it was called Rosyanka in Russian, Drosera, or this name, because at the moment there is no this Droseras on this area, because it's totally wet.
Sorry, we must come to an end.
And this is how it was in the end of June. And you see in the corner, in the right corner, how it looks now. And also on the 17th of November, the governor opened this farm on Vidgirinsky. We also participated. It's a story about cooperation between different institutions and the government of Kaliningrad region. And me personally, I really hope that it would be rewetted in quite short term. Thank you so much.
Thank you very much, Amal. I think there's no time now for discussion, and we would have to go to the next presentation, how to use the Neiman Catchment Peatland database, presented by, I think, by Michael Manton, Leonas Yarosios, and Andrzej Kamotsky. So please, it's up to you.
So can you hang on, let's see. So you can now see my screen, I take it.
Not the presentation mode until now?
No, I'm trying to get rid of people's faces.
Yeah, okay.
Okay, so now you've got the, here we go.
Now it's the presenter mode.
There we go.
With double,
so
there's a double screen now. With the
you have a double screen?
Yeah, with the preview to the next slide.
You have to change under the display settings. You have to change the monitors so that we see the presentation.
There we go.
Or put slideshow. It helps. You have to see it on the corner.
Yeah, I've only got one screen up,
Or the reading mode is also possible.
where am I going here? Because I only got one screen plugged in.
It's the wrong one.
Well, it's the laptop computer, so.
Michael, go up to the display settings exactly and swap this.
Yeah, it's grayed out, so. Oh, this is ridiculous.
Or go into the reading mode. That's also possible. That's better.
And let me stop again and. Okay, let's try again, see what happens here. Okay, now you've got one screen.
Yes.
Okay, live demonstrations, great that they work. So my name is Michael, I'm a researcher from Vytautas Magnus. Today I'm going to present on, within the Desire project, we created a spatial database of all the peatlands within the Neiman river catchment. So this is pulling peatlands from 4 countries together, which hasn't been done before, and to put them online. So this task was undertaken mainly by the Lithuanian Fund for Nature. That was their activity with Nereus, and I was part of that, helping them from Vytautas Magnus University. We also had cooperation from Poland with Andrzej from, I think it's Białystok University, and also from our partners in Kaliningrad with Maxim. So I will just go to the website now. This is the address. Make sure you use it and see it, play around. You can't break it. So when you open it up, of course, it will change in the top to the actual GIS server where it is. First, it will open up to sort of a welcome screen to explain that it comes from the Desire project and the main partners here. So so you just click OK, and you will come to the map. Now, for some people, the menu will be on the right. For some people, it will be on the left. We're not sure why this changes. So what you see today is I generally have it on the right. Normally, everyone else has it on the left. So what we have here is, this is our list of layers, our content. You can turn them on, you can turn them off. When you're zoomed out, they may not all show, because some of them, so as you see that when they're grayed out, they will not show. This sort of highlights the visibility. So what you're seeing now at the moment is not the peatlands, but you're seeing a 1 kilometer grid cell with the area proportion of peatlands per hexagon cell for 1 kilometer. So if we zoom in, I will try and zoom in over here where we've been talking about today in previous talks, Rewetting Biosphere Reserve. So here you see the hexagons, and you can see the actual proportions, especially if we expand here. You see the dark is 80 to 100% peatlands within those cells. So this is just an overall, because it's very labor intensive to show all peatlands. I can try and show this if I go back to the home screen. So this is, so as you see, it won't show at the moment, but if you go over here and click on the 3 dots, you can set the visibility range. So at the moment, we are zoomed out to this. This is the current map scale, and this is where the visibility range is set. So you can drag this, and you see that the peatlands will appear, but this is very resource heavy. So, and within this peatland layer, so this peatland layer, it contains all the attribution that we've been able to put. So at the moment it's showing peatland type. This usage of peatlands, it's the same layer, it's just filtered with a different, these are just layered with different, I guess, selections for showing what's on the map. But as you see, so there's a bit of difference in the scale of peatlands. The minimum hectare is 1 hectare size for peatlands, up to whatever they go. It stretches across Lithuania into Belarus. We don't have the same precision in Belarus, and we're currently working on this, but I don't think we'll get to such small peatland sizes in Belarus. Whereas in Poland, each individual peatland was GPS and mapped, so field verified. Same within in the Russian area. So this is new data that's never been available before at such precision. And again, we have Lithuania. So this data can be used to view what's in the peatlands and so forth. So one of the key aspects is if you click, well, let's see if I can get it. You can click select here. Nothing's happening. Try again. Select. So what you can do is there's a select feature. And then now I can, so you pick the select feature, it comes up with select. You can pick what layers you want to select. I'm mainly interested in the peatlands. You can select everything, or you can select a small area. I'll select a small area here around Juventus without zooming in. And it's highlighted these areas. Now, if I click on these 3 dots over here, I can pan to sisters. But what you can do is you can export the data to a shapefile. So I'm not going to press it now. I will just click to one that I did earlier, and it shows you the data behind the shapefile. So this is the attribution that we've put to each peatland within the Neiman River Basin. So we have different peatland types, if they've been impacted by drainage, the land use or the land cover, if they're protected or if they're not protected. For Lithuania, also if they're within the habitat type within the EU habitats directory, your country, your area, your sub-basin, and then you have a cluster to say, as you see, I will go back and explain the cluster. So you see all the peatlands, they're so fragmented in Lithuania and Poland. So we run a cluster analysis to group the hotspots. These are key areas where there's high proportions of peatlands that are significantly connected together to form, say, a peatland landscape. So this is all contained within the peatlands data. So my suggestion is for those who use GIS, I would select the whole database and download it. You can download it to a JSON or a feature collection, or you can save it if you have an ArcGIS account. So there's all different methods you can do. I will clear this selection now. You have to sort of remember where you are when you drive this, because now you see I'm still on the select, but the layer functions has disappeared. So now I just close that and I come back to the layers. So we'll just go through them again. We have the Neiman River Basin. We have the peatlands, a different type. Then we also have, let's zoom in so maybe it's a bit quicker. So here we have a layer for horticulture. It's only for Lithuania. So if we zoom this out, we can see what areas are not suitable and what areas are suitable. So this was an area Matush and Neris were talking about today. And there was also some other areas over here. If we turn that off and we go to next and we turn it on. So this is the land covers. Again, you can see there's natural peatland, semi-natural grassland, forest, pastures and meadows, agricultural land, quarries. You may find in some places water and you may find urban areas. So this is all here. Then as well, you have restoration. So in part of my activities in spatial planning, I was to, this is really working well today. We made an assessment on the spatial planning for peatlands and conservation throughout the Neiman River. And we classified each of the peatlands for their status on high priority for restoration and conservation, or low priority. So low priority means that the area is already conserved and it has no drainage. So there's different aspects about what you can do and what you can't do for priority. I'm not going to go into the ins and outs of this. That's a whole different study. You can read the paper, which I'll show again later. And I think that's where I'll stop today. So if there's any sort of questions.
Thank you very much, Michael. Maybe one question is possible, and then we should go to the next presentation. But there seems not to be any question now, so please ask your questions in the breakout group that is also where Michael is joining. And then we come to our guest speaker today, Frank Bortgaard from Zemes in Denmark, who will talk about rewetting and polyculture experiences and present some examples from Denmark. So please, Frank, it's yours.
Yes, thank you very much. Sandis, you promised me to help me, so I can better manage. So please show the next slide. We don't have so many experiments with palodiculture as a production in Denmark with palodicultures, but the last 2 years we have got in cooperation with the Aarhus University and the Canopy project, who is in the Canopy is managed by the Nature Agency in Denmark. So, and I'm working in the advisory service, the farmers' own advisory service at Zemes. So we are working together with this, and this picture is from the site Canopy have done in the biggest raised bog in Denmark. There is about nearly about 2,000 hectares, and if you look at the right picture, you can see the raised bog at the left side, and we have this field experiment with red canary grass and festuca and taipa. And yes, this year we should do this experiment. There was a drought in spring, and it's quite hard to work with a higher water level when you have drainage canals and still have potato growers at and drought in a raised bog. You need to work with very high water levels in the start when you want to make taipa fields. So we didn't succeed here, but the red canary grass, you can see we are harvesting at the right, and the vesicle, they was growing very well, and we had without fertilizers and with fertilizers. And it's in Denmark, I think we will have a challenge with this fertilizers in rewetted areas. So one of the things in Denmark is that there is more focus to have nature in this area than production. But what we have done here, and I don't have the results yet, but the yields was quite good in the grass, and we have now tried to take protein out of the grass in these plots and see what the economy, because we are breaking the code how to take protein out of grass and feed pig with grass protein. So that could be a way to do it. So, but I don't have the results yet. So Sanis, try to the next picture. It's I think that we at Seges, where I'm working, we have focus on more. Could we have paludicultures in the river valleys where there's come a lot of nutrient-rich water? And here is a student who dig by himself this field, this with a spade with his hands, and he tried to establish typa, and only for but where we have put seed, there was coming no plants. It was only where he was planting typa. But we succeed to show that it is possible, and we will follow this side. I think that the next years there also will be typa in the whole plot here. But I think that we could have very good places to clean the water from huge catchments who are coming into these river valleys. But it's very hard for us in Denmark to get the money for this research. But we have not we are not finished yet. So that is one way, production, or the other way could be nature. So if you look at the next slides, then the Nature Agency have been harvesting 900 hectares out at the farmers, where we have very wet areas, and they have got a lot of money for a new harvest machine, because it's very important that you make this grass in small pieces before it go to the biogas plants. And the big vision is that you take the protein out of the grass and then put the rest of it in a biogas plant. But at the moment, the farmers pay the Nature Agency about 70 euro to harvest, and then they are sure to get the single payment. But the Nature Agency have not succeeded to earn money on it yet. That's the main problem. But the machine is underway. So I think the next years we'll see a new machine. And here you see the same field plot, and what the Nature Agency is now, it's very hard to get potato growers. There's a lot of potato growers in this area. So they use these membranes 4 or 5 meters high and make a dam. So you can see you have the raised bog at the one side and the potato farmers in the other side. You can't see the potatoes here because it's field plots where the people are going. So they are going to fence in the same area 400 hectares with these membranes next year, because if you will pay the farmers out, it's quite tough. You have to send 1 billion maybe to them. So that is not the solution yet. So if you take the next slide, there is a very hot discussion in Denmark about the climate now. So we have to take out these 88,000 hectares out of production and extensive. And you know, some should be rewetted and some should be nature. So the goal is now 100,000 hectares, and we have 170 1,000 hectares with carbon-rich soils, and the problem is that they are still in crop rotation. A lot of them. There is 107,000 hectares in crop rotation still, and 50,000 in permanent grass. So, and we have a huge problem with taking these. I think the Nature Agency have been looking at 7,000 hectares, and they have only succeeded to take 1,600 hectares out of production because of phosphorus. There's high content of phosphorus. So when you rewet this land, you send a lot of phosphorus out in the lake. So now there is coming a new scheme next year to harvest 6,000 hectares to prepare them for rewetting. So that is a new eco scheme in Denmark. So if you take the next slide, in last week the state made a higher one-time compensation to the farmers, so they can choose this one-time compensation, or they can go into land consolidation. So there's an allocated 2 billion Danish kroner so that is not enough, but it's a start to take these areas out of production. And if you take the next slide, we are the next years going to involve the landowners. How do they see at it? But we have been working with this topic with the wetlands in Denmark in more than 20 years. So we have a good setup for doing it. And when they have this higher one-time compensation, it should be easier. So if you take the next slide. So we have a plan that we first have the meeting with the landowners, and then they could go home in the internet and point out what kind of fields do they want to take out of production. That we have established this year, this program, so they can go home, but because it can be hard to get the farmers to say that what they are going to do, and they also have to think about it. And if you take the next slide. In Denmark, we have this property study. There is people who are traveling around to all the farmers to ask them what they want, and then we make this technical study. How will the water level be afterwards, the project? So you can see that at the left side. And it's very important that you don't make backwater problems in the drainage system. So this technical study for these lowlands are very important. So otherwise you just get a lot of trouble. So if you take the next slide, it's a very democratic process, because the farmers, they value their own land together with the agriculture agency in Denmark. So they go around to all the fields in the area, in these organic soils, and you also will have other soil types. So they make if you take the next slide, you can see they make a map. So they always go to the best field and make that 100, and then you can see a lot of the organic soils, they have maybe 20 or 50 or so that is how they decide what is the land price in this area, and they do it together. It's very important that the farmers are part of it. So that is a way to take out all these wetlands out of production, organic soils out of production. So if you look at the next slide, one of the main problems in Denmark is that we have so many landowners from the past in all these areas. They have in the past, it was very important that they all had a field in the lowlands, so they had land to their grazing cattle in the summer when it was drought. So here you can see at the right side, it's before and after they have remeandering the stream and have raised the bottom of the stream, so you can get water into the peat soils. And they sometimes they succeed to have farmers get bigger fields, but not always. But it take between 3 or 7 years before a project like this you have been running this project before it's finished, and then you also have this climate effect. So it can be tough to convince the farmers to do this, but it's the way, in my eyes, to do it. And the next slide, it's at the moment in Denmark, the first step is to find out rewet organic soils or making wetlands, because you should do that before you make constructed wetlands, because you have a huge effect of rewetting organic soils and wetlands than you have of constructed wetlands. And that is a great topic in Denmark, because how do we do that? But in my eyes, we have to ask the farmers for the wetlands first and rewetting organic soils, and then you also can have constructed wetlands. So if you take the next slide, you can see. I really don't know. It can be hard out and realize to see is it a wetland or is it a organic soils with a higher water table, because in the landscape they in Denmark somewhere look the same. So and it's also complicated because you have often a mix of wetlands or with sandy soils, clay soils, and organic soils. So we have very fixed schemes in Denmark, and I'm a bit fixed schemes because you need to do something that the landowners think is a good idea and what can the landscape deliver. But we have a lot of Excel sheets that you should have so much effect and so on. But last week they dropped them because you have to look at the landscape and what it can deliver. And I think that we one day will come to this conclusion. But we are not there yet, sorry. Yeah, that was what I'm going to say. So it's not only paludicultures, but in my eyes, a lot of these areas will become paludicultures because the farmers are still allowed to harvest and grazing cattle. But I just have to say, some of it will become lakes because the earth is not flat. So you have a combination in many areas of everything. But the phosphorus is a huge challenge for us. We are working with it still.
So thank you very much, Frank, for this presentation. I think Denmark is seems to be on the right way. Although that's a big challenge. Anyway, for all other countries, it's the same. It's a big challenge to rewet all the peatlands, and some of them bring to paludiculture. Is there one question maybe? There's a hand from Dominic. Please make it short.
No, Nereus was first, so I go back.
It's okay. I mean, we can discuss it later in breakup groups, okay?
Yeah.
Yeah, thanks, Frank. It was really a nice insight. I know, of course, many things of this because I live also in Denmark now.
Yeah.
But I'm interested in a very much detailed thing, maybe not the right place to discuss, but can you shortly say this protein extraction, is it a common thing and is it easy? Is it cheap? Or can you just say 2 sentences on that?
We are only in the start, but I think it's also it's a huge topic for organic farmers, because if you don't have cows and you want to have a clover, in my if you're not allowed in Denmark, the organic farmers still get conventional manure from the conventional farms. But in the future, if you want to be an organic farmer, you are maybe on your own, and then you need the clover fields. And if you don't want the cows, you maybe need we are only in the beginning, but there is a farm in Denmark who have they go to have grass fields with clovers. They will extract the protein and they will make biogas. Then you have a cow in your farm also, because I don't believe in organic farms without cows. That is I'm an older farmer son, so and in the past all farmers have cows, so you have to make another setup. So that is more the direction than. But we have so much grasses out in these areas in the future, but we have no cows, so we get fewer and fewer cows in Denmark. So I think that if you want to keep the landscapes light open, you need to harvest these areas. That is at the moment it's in the legislation in Denmark that they should keep light open. But in my eyes, if you are talking about the climate, leave them. Set them on the water and leave them. That is the most climate friendly. But it's not like this. EU and the Danish state look at it. But in my eyes, the most climate friendly way is to put them on water and leave them. But then you have a lot of trouble with the birds who is moving around because they are connected to the farmers. So they will get willow areas and bushes. You can see that in the other. So that's why the nature agency is working with this machine, is to keep them light open, because they are very important for the traveling birds. So I don't think that it's not so easy, because then they will land in the bushes. But we are working with it's tricky to work with the nature and the total setup, because the birds are connected to the farmers.
Okay.
Thank you for now. Maybe you can go deeper in bilateral discussion. Because we are running out of time a little bit. So then we would come to our next presentation, presented by Piotr Banaszczuk, Andrzej Kamotsky, and Achim Schäfer, about the utilization and economy of biomass from wet peatlands. And I see the presentation is already on screen.
Thank you, Vendelian. Good morning, everyone. My name is Piotr, and I will deliver shortly about energetical use of polluted biomass, focusing on biogas production because of some reasons. And right now, look at the tree. I like Frank and his statement. Working with the nature is tricky. It's really tricky. And when we decide to rewet degraded peatlands, so if we say yes on the right side, sooner or later we come to these abundant biomass ecosystems, independent whether it's polyculture, whether it's biomass from conservation management of conservation of protected area. What kind of biomass? It's a lot of different species. Of course, it's a lot of different combination. But when we're looking at this example, on the right side, we see grasslands, degraded, drained. On peatland, it's a combination of several grasses and other species. And after rewetting, we will have 3 or more most typical combination, which is the halophytes with a high biomass production, Typha latifolia and Phragmites. It could be also a combination of different carex species. And the third combination could be some admixture of grasses like Alopecorus and other plants. So using of such kind of wet regions of wet peatlands, it was a very traditional way of doing agriculture in Poland, and I think in most of Eastern Europe. We can see on this slide a picture from 1960s. And this Narew River Valley. We can see this fantastic anastomosing river system, but most important is this a lot of these wide points. It's a high stocks. We can see this on the picture on the right upper right corner. It's older one. Of course, right now the mowing and gaining biomass is not made anymore using hand side. We now use machinery, like this one on the picture. This in the lower right side is most typical. Is the redesigned trial groomer or snowcat. which can easily move through rewetted wetland. And in Poland, in two valleys, I mean Biebrza River Valley and Narew, thousands of hectares are right now mown. But the problem is what to do with the biomass. It's sometimes considered as annoying waste, and it's stored on the valley edge, on the very outskirts, as on an example on the left side. So in our investigation, we focused on biogas generation because of many reasons. First, it was independent that this technology is more expensive and more sophisticated compared to direct combustion. Making biogas, we have some positive or advantages. First of all, it's a flexibility in energy generation, including energy storage in form of methane, for example. And point number two is conservation of nutrients, conservation of phosphorus, nitrogen, and of course carbon, which can be used as soil amendments in crop fields. And just like is shown on this very simple diagram, we can produce a kind of closing of a loop of circular economy when mown biomass is transported to biogas, is supplying with heat and electricity houses all around, and digested is landing again on crop fields, increasing the amount of nutrients. And of course, some portion of this nutrients after that is transported with erosion or groundwater to the wetland again. So we tried to investigate three paludy biomass combination. First is Phragmites. The second is a mixture of Carex salata and Carex gracilis, which is quite common in the investigated basin. Third, wet meadows, so grasses with some admixture of Carex, and compare it to maize silage. So the first results were not very optimistic because our paludy biomass was or has much less biomass yield compared to maize, and of course the production of biogas of methane from late mown Phragmites and Carex was much lower compared to maize. But there is some optimistic remarks on this picture, because when you look on these whiskers, we can see that in some cases production of Phragmites in ton dry weight per hectare can be much higher than this conservative data we used for our calculation. And when we will cut the biomass earlier, not at the turn of September and October, or in October, like in this case, we can also obtain a higher yield of methane. So it could make paludy biomass comparable to maize results. And on the right side, we can see energy inputs and energy outputs per 1 hectare of paludy biomass and maize. And again, we can see that input for mowing and processing of biomass is much lower compared to maize. That's quite obvious result. But also in the same, we have in the case of maize, energy output per hectare an order of magnitude higher. But the next point, it was comparison of or assessment of life cycles. So how many kilograms or grams of carbon CO2 equivalents we can produce during all this process per 1 kilowatt hour of electricity. It's important, it's only electricity. On this picture, we can see the red line, which is 1 kilogram or 1,000 grams of CO2 equivalent per 1 kilowatt hour electricity. It's most emissive electricity generation from coal, and to that value we tried to compare our results for paludi biomass. 3 scenarios. Let's start from number 3, which is the best, of course. So calculation made according to Renewable Energy Directive 2. Our calculations show that emission is really nice. This is this gray line in the center, in the middle of diagram, showing that compared to coal, which is the most common energy carrier in Poland right now, using the biomass, we are the best. But when we include in this LCA also management of digestate and emission caused by manufacturing, processing, machinery, and raw materials and so on, the situation will be less optimistic and more pessimistic. Just look at this blue line. It's the highest emission possible when we include all steps into this process. So we are best performing compared to coal only in case of dry fermentation of few feedstocks. But it's not end. I have also good message to you, because all these calculations, I show you where is the catch in all these calculations. But right now, short information about energy flow. It's also calculated per 1 kilo per 1 hectare. Situation is called in gigajoule. We try to compare very promising dry fermentation of Phragmites, which is most promising technology, I think, when we were talking about biogas production, and most common right now in Europe situation when we are talking about biogas, it's maize. So situation is quite obvious. Performing with maize, we can get much more heat and energy. It's approximately altogether 100 gigajoule per 1 hectare. When we are doing the same story with Phragmites, we can obtain 20 gigajoule per hectare, so 5 times less. But look at this pillow down on the lower part of this picture. It's energy we can put into the fields together with carbon and other nutrients. So situation, to summing up, looks like that. When we are making LCA for the all steps from the cradle to grave or from the cradle to cradle, only dry fermentation of Phragmites and dry fermentation of mixture Carex salata and Carex gracilis are better compared to coal. But of course, when we are doing the same story according to methodology of Renewable Energy Directive, the situation is brilliant. We are reducing emission by 74% for Phragmites, dependent on the technology. It could be even higher by up to 85%. So as I told you, where is the hook? This calculation was shown only per 1 kilowatt hours of electricity, and making biogas, we have also heat. And heat and electricity, so we can say that 50-50 is electricity in relation to heat. So all these results will be much better. Next point, doing this energy from paludi biomass, I can say we can save the world, but we can conserve the biodiversity. We can remove the nutrients from the ecosystem. So it's a really a positive activity compared to environmental burdens, which are really connected to energy crops like maize, for example, which is considered to be really harmful every components of the ecosystem. And the next point, we are really don't know how high is the actual emission caused by incineration of coal and this coal-based energy. So all these calculations are showing only that it could be some problem inside, but in reality, using the biomass from a polludiculture or conservation measure is really very optimistic and promising option for generation of energy and conservation of nutrients. And that was my message for the end. Thank you for your attention.
Piotr, thank you very much. Is there one question that can be answered very shortly by maybe Dominic? Your hand is up.
No, I was just giving applause. It was very nice. Thanks.
Oh, okay.
Yeah.
So
thank you, Dominic. No question from you. It's a success.
Actually, no, I have questions, but we can discuss it in a breakout group. Yeah.
Yeah, thank you. Of course,
yeah.
It was only very short demonstration of our calculation. We did much more in this area.
But really good. Yeah, thanks, really. Yeah.
Okay, thanks also from my side again. And now we come to the last not least presentation presented by Jan Peters, Thomas Schwilk, and Achim Schäfer. So please start.
Yeah, good morning, everyone.
Can you see the presentation?
Yes, we see it. So I will start with the first part, and then Thomas will take over in the second part. So we will talk about the work of the Desire project on peatland policies, environmental schemes, so the CAP and eco schemes for rewetted peatlands. Next, please.
So next, please.
Yes, but
it's not working.
Okay.
So first of all, I just wanted to show you that peatlands are quite prominently distributed, of course, in the Baltic Sea region. On the upper left side, on this little greenish map, you see that most of the countries around the Baltic Sea have quite high peatland distribution areas. And on the main map, the red map, you see that also in most of the countries, especially of the southern and eastern part of the Baltic Sea region, the degradation of peatlands is quite high due to drainage. A recent study found that of European peatlands, 25% are degraded. In the EU countries, member states, even 50%. And that leads, among other environmental harm, to the fact that 220 megatons of CO2 is emitted every year, which is 5% of total EU greenhouse gas emissions. Next, please. And just to give you a broad overview, that peatlands in the EU policy framework are featured in many different policies. It's a quite complex complex field. As you can see here, they are, of course, financial things play a role. The agriculture policies are very important, structural and cohesion policies. Of course, the biodiversity and conservation with Natura 2000, Habitats Directive, Bird Directive are important. The water policies, which play an important role for nutrient retention, which we deal in the Desire projects with the Water Framework Directive and the Flood Directive. Also the soil policies. Just 2 days ago, the EU Commission published the new soil strategy for EU, which will now go into discussion within the EU organs. And then we have, of course, climate and energy things, research, and also parts of horticulture. And all this should be kind of under the umbrella of the EU Green Deal. So it's a very complex picture. And next, please, we will mostly focus here on the CAP, so on the Common Agricultural Policy related tools. Why is this so important for peatland protection? Because actually drainage-based utilization of organic soils, peatlands lead to high greenhouse gas emissions and nutrient loads to groundwater and open waters. And the change to peatland rewetting and paludiculture can reduce these emissions and also leads what our desire project shows to around 50% reduction of nutrients from the peatland catchment. So CAP instruments in the European Union can support the process of a paradigm change on the landscape scale. Next, please. We need wise solutions under the CAP dealing with water retention and paludiculture to change from what you see on the left, the drainage-based agriculture leading to the described harm, to a more nature-inclusive form of agriculture in paludiculture, what we already saw, for example, in the presentation from Nergios on the examples from Lithuania. Next, please. So the CAP so far remains the main driver actually of peatland degradation due to the payments for drainage-based agriculture, which is actually increasing the competitiveness artificially, as many of these areas, especially in the Baltic region, are actually marginal lands, and some of them are only kept in drainage-based agriculture due to these direct payments of the EU. And on the other hand, we have the situation that changing to paludiculture, land use system to paludiculture, is connected with the loss of these direct payments, as certain paludi plants are not regarded as agricultural crops. So we need in the new CAP, which is about to start next year, an approval of paludiculture as common agriculture and moving towards that. And this is our desire project made like concrete proposals how that could look like. Next, please. So, and for these examples, how that could look like, what are the schemes in place or in development, and what the desire project did, I would give over to Tomasz, please.
Thank you very much. Tomasz Wilk, Polish Society for the Protection of Birds. So Jan gave nice overview of the problem, and so let's think when to look for solutions. First, I will give you some examples that some solutions are already in place, and examples of existing measures in the Baltic countries are operating already. For example, in Finland, we have this buffer zone protection program within non-productive investments of rural development program funds. In Sweden, we have agri-environmental scheme designated for construction of new wetlands, new small wetlands. In Germany, in Brandenburg, we have an agri-environmental package aiming for water retention and designed with the climate, for climate reasons mostly, but obviously providing also other benefits like drought resilience, for example. And we have, or we probably will have a nice example also from Lithuania, for example, where within this recovery and resilience facility funds, some nice amount of euros will be provided for peatlands restoration next years. And as we've heard two presentations ago, also some nice schemes are operating also in Denmark, for example. So there are some good examples working, but still too few. And we have some tools regarding water retention operating in place, but especially regarding paludiculture, there is not much going on in this field. And this is so we need more solutions and practical tools in this area. And also because of the EU biodiversity strategy, but we can also think the other way around about the strategy. So strategy gives us, in my opinion, also a special chance for pushing for new solutions regarding peatland conservation. And one of example of this kind of pushing for good solutions, I will present the example from Poland, prepared within the Desire project. So we had this 2.5 activity within the Desire project, which was aiming to prepare a proposal of agri-environmental schemes for water retention and for paludiculture. So we have prepared such proposal in Polish and in English. In this proposal, we reviewed the existing financial tools in different European countries. We provide some arguments that this is important. And we obviously provide also the detailed description of the schemes itself. For the water retention, we had like a separate schemes or even 2 separate schemes proposed. And for paludiculture, we proposed, I'm saying now about the Poland. I'm not sure if that was clear. And for paludiculture, we proposed, instead of separate scheme, rather a set of small notions for different legislative documents. Yes, that was because the paludiculture is not really working now in Poland, so it was hard to propose something big for this area. And we succeeded basically. So now we have agreed by the Ministry of Agriculture the eco scheme called water retention in Poland. So this is a good news. A little bit bad news is that the Ministry of Agriculture wants to narrow down this eco scheme only to areas which are covered by the agri-environmental scheme payments. So this will reduce very much the potential for the water retention eco scheme implementation. But we are still in the discussion, not only we as Otto, but of course other organizations in Poland, partially within the coalition Agriculture for Nature. We are still in discussion with the Ministry of Agriculture, and we are pushing for changing this limitation of eco scheme usage, but also for some solutions for paludiculture. We have now the third version of the strategic plan for Poland. So the work is still ongoing. So if I should conclude, I would like to start first with the fact that when we think about the peatland protection, water retention, we think about, in most cases, we think about local projects, conservation projects, but this is not enough. Yes, we need really a wide strategic program. And regarding the details of such program, some first steps are already made, but we need more, obviously. All EU and national policies should be aligned with the Paris Agreement targets. Peatland conservation should be a kind of a cross-cutting issue, because it brings together really different types of environmental problems, let's say. Yes, so climate, biodiversity, drought resilience, etc. We should work more together. I mean, within the EU, also for like the big changes regarding, for example, the change of legislation. And as also, for example, it was from Piotr, what was clear from Piotr's presentation, and not only, also from the Frank from Denmark, really different stakeholders are involved in the process of peatland conservation. So we need really like participatory approach, and we need to work together. And again, we need to engage very much private sector, because we will have a large amount of biomass and we should process it somehow. Yes, and the last slide, there is this proverb which I like very much, that one hit in a tree trunk is worth cutting 1,000 leaves. And I like to think about this policy work as hitting in the tree trunk, because this is kind of work which we don't like really much. It's not as pleasant as field work, for example, but it can give really wide, long-term and important effects. So yes, everyone should participate if possible. Thank you very much.
Thank you very much, Tomasz. Are there any short questions? That seems not to be the case. So then we come to some organizational issues referring to the part of our meeting today. And I share the screen for the time plan for the second part. So we now would go into different groups, breakout groups, and discuss special things that are mentioned here in the description of the groups. And we now thought about founding another group as the group E for the Russian-speaking participants, so that they can discuss in Russian and find an English-speaking person who will present the results in the last part in the reports from the groups and by the rapporteurs. So each group has a facilitator that is mentioned here also in the schedule, and in every group, a rapporteur should be selected, that somebody who takes notes and will present the outcomes of the breakout group in the plenum afterwards. So I now propose that we change the schedule a little bit, so we will be only a little bit later at the end of the workshop, quarter of an hour, something like that. So that would mean that we would start the breakout groups at 11 o'clock and they will last until 11:40. Then the conclusions will be done starting from 11:40 to 12:10, and finally we will have the possibility to end up at 12:15. Sandis, do you have any further recommendations and instructions how to go on?
Not from my side. I will then create 5 groups, and I would just ask the participants to choose the group for themselves, which you prefer. But yes, we will create the 5th group for the Russian-speaking participants so that they could speak in the Russian without the translation.
Mm-hmm. Okay, so you open these breakout groups and everybody can decide by himself?
Yes, they can choose from group A, B, C, and D, and the Russian speakers will choose E group. We just should assign a topic for this 5th group.
Come back to the plenum, and I hope that that you had fruitful discussions in the breakout groups, and we will directly start now with some reporting from the groups and should start with Group A. So please give some short report.
Okay, I will share the screen again. So we had a very small group. There was Martha, myself, and Pavel, and we sort of discussed about the database and how we can proceed in using this and what are the next steps. And we sort of well, Martha and I we've both worked in detail with the database. And we come up with a few problems and benefits. So we sort of found that problems is the data quality can be lacking, especially for Belarus. We thought the data for Lithuania, Poland, Belarus, and Kaliningrad was acceptable. Problem can be the scale. So it's broad scale in Belarus, as the others are very, very specific, down to 1 hectare. So there's quite difference. The definitions of what things mean within the database, there can be also misleading, such as land use or land cover. It says natural peatlands. What is that? Doesn't say if it's a forest or if it's a grassland. Sometimes we're missing data, such as ownership, drainage functionality. Do they actually drain? One of the next ones probably is the upkeep cost and who. I mean, we've made this nice database, nice website. Who's taking care of the upcharge? Who's going to keep using this? The next is upscaling of the data for users. Okay, we've applied it in some spatial analysis for protection, rewetting, and these things. Integration of on the online website's a bit hard, but it's good for viewing. So there's time consuming in the data. Comes back to the online mapping restraints. I guess if we look at the benefits, broad scale data that was not available before now to do actually spatial planning at a broad scale for policies and rewetting actions. It's a transporter database, so you expect there to be some differences. It's freely available, so everybody can use it. It's not locked up. And as we said, it's good for broad scale assessments, so such as Martha's work on rewetting with Matush, cost benefits or protection status. It's really the first step for doing, I hope, what a lot of the other groups were talking about. So we think the data is good for spatial planning, and we look forward to hearing what the other groups have.
Okay, thank you very much. Are there any comments on that? From the group or from externals, any questions? That seems not to be the case, so we come to group.
Yeah, I have one.
Yeah, please.
I think if from our perspective, they are not like peatlands and wetlands. They are not easy in terms of data collection and the scales and so on, all the things that have been mentioned. But even though it's worth the try to put it together at the end, because at the end, every country has their own information. But even if it's a bad information, it's informative. So it's really worth trying to put it together, which is very, very difficult also in the terms of the peatlands, but
yeah,
very valuable.
It should be said that the Russian and Belarusian data, this was not available before now. You could view the Belarusian data, but you couldn't get it. So that's a first really good step.
And they will be additionally improved in the next
future.
weeks. Yeah.
Yep. Maybe I can also just say what I meant I said already in the chat. Yeah, for me it was so impressive to see it. Really, it is. It's amazing, and I really wonder. It must be it must be a full-time position actually. Yeah, for many years. Yeah, to make it run. But is there any option maybe to really proceed with this one, or is it only project time again which decides over it?
So the Lithuanian Fund for Nature has been able to budget to keep the website up and running through the ArcGIS interface. I think that's for the next 10 years. But I think it will take some projects and some extra money if we want to keep it updated. So when there's a restoration project to actually translate it, somebody has to go in and update the data.
May I comment just to add, not for 10 years, but for the Interreg, the duration plus 1, 5 plus 1, so it's not exactly 10, but doesn't matter because it's always tricky how to pay for the services and those volumes of data. But another point is that this database, I don't know if you discussed, it is not precise anyway. This delineation of peatlands, you see, this peatland database is based on soil maps which are from Soviet times, some 40, 50 years old, yes? And some of the data, those peatland data, which we say now that there is peatland, in fact, it might be no peatland anymore because it was because of the degradation.
Is this for Lithuania or for Belarus?
I think for Belarus, the situation is the same. In all these post-Soviet republics, we have had the same system of soil databases in Soviet times.
But we can say that Kaliningrad and Poland, they are 100% right.
I don't know about Poland, but I heard that in Germany, they also use old maps. And in fact, what I want to say that when you come to the concrete to the farmer and you say that you have a peatland, and in fact might be there is no peatland anymore according to the definition we use, like 0.4 meters of peat layer. So this is still a big problem in the finding in the peatlands in mapping. So nobody knows how to solve it so far.
That's my idea why in Poland they are 100% right, because in Poland actually the peatlands, drained peatlands, have never been arable lands. Somehow they managed to do that. They are the worst what have been done to the peatlands is pastures or meadows.
I'm saying the Poland data is right because Andrei went out and GPSed them all.
Yeah. I know, but yeah, why they don't disappear, all the peatlands, maybe that they were not disappearing so fast.
No, they are disappearing like hell. My short contribution, when it was thin peat layer up to 60, 70 centimeters, to imagine that after drainage, its subsidence can reach up to 10, 20 centimeters. And after that, you can leave. You can lose 1 centimeter a year. It's a very average information, but so 30, 40 years of usage and there is no peat layer at all.
Yeah, but if you compare it to the arable lands, for example,
let's not go into discussion because we don't have time.
Yeah, I think we have to stop and go to group number B. Who is the reporter there? And
yes. Give me a sec. Sure. I'm reporter. We have short discussion about biomass and challenges, how to use this biomass and how to convince farmers or entrepreneurs to use biomass originated from rewetted peatlands. So we know that peatlands must be wet, as you know that this paludiculture paradigm will need to be shifted toward completely different use of biomass originated in them. But our discussion shown that in Lithuania, but also in Poland, and I suppose in other countries,
there is a lack of social awareness that we need to change our attitude toward rewetted peatlands. So farmers are really convinced to do their business as usual, especially in that places where dairy production is highly developed. In some places in Northeast Poland, we can see this process. There is no money to convince the farmers, people, let's start to do something else and rewet your grasslands and cut biomass. So social awareness is number one. Policy and technology. So without good political encouragement and cheaper technology, is also very difficult to have high scale or big scale generation of energy from biomass in rewetted peatlands, because as you know probably, the biogas production is very expensive. It's not only harvesting of biomass, but also not only operation costs, but investment costs. So construction of biogas plants is really a challenge. And the next point is money and subsidy and some other way how to convince farmers to resign or put away today's way of agricultural use of peatlands and switch towards most environmental friendly solutions. So that's the results of our short discussion in our group B.
Thank you very much. Are there short comments on that? If not, we would come to group C. Significance of rewetting and polyculture for nutrients and so on. And I'd like to ask Irina to give some short overview on the results.
Yes, so what we have discussed about was that actually there are still many questions to be answered regarding the polyculture implementation. Well, this is somehow connected to what Piotr just said. Like some information, some basic information is not actually known or realized by the scientists as well, not mentioning just stakeholders or policymakers. For example, we discussed the effect of nutrient leaching from the polyculture, and if the greenhouse gas emissions are actually reduced after rewetting. So this kind of information, even the basic one, should be somehow spread more. But also what we want to say is that there are some improvements in the policies, and yeah, this information is anyway spreading. And for example, there are some improvements in regarding the agro-environmental schemes nowadays. Yeah, so I think that's basically it. Maybe Wendelin, you want to add something?
Yeah, maybe the methane discussion. So some participants feared that the methane is is emitted in larger amounts directly after rewetting. So for all those who have doubts on that, they should go to Günther et al. Nature Communications, where the methane problem has been relevated somehow. Is there any other comment on that session? If not, then we would come to group D, peatland policies, instruments and incentives to support economic feasibility of polyculture. I don't know who wants to report.
I will quickly report. So we also had a very interesting discussion, actually also covering some points which have been already mentioned from the other from the other groups. We were discussing about, first of all, which levels are actually instrumental to make peatland restoration and paludiculture happen. And we kind of discussed that there should be, on the EU level, better synergies of different policy sectors like water, agriculture, climate, biodiversity should work more in synergy to enable member states and local actors to engage more in this, but also the local levels and the communities, the involvement is very crucial to make things happen. As already said from other groups, awareness raising on this issue of peatlands, how much they actually contribute to the climate catastrophe and also to the nutrients in the water, because you cannot see that, you are not aware of that. If you haven't heard, that is quite crucial. Then we touched upon quite intensively on economic issues as well, as one of the major issues is that after rewetting, the land itself loses a lot of its value. So farmers, landowners who do that will actually lose most of their property, their value of their property, and banks, mortgage companies will of course not accept that. So there need to be other ways of kind of compensate for that, for example, by public money, which is happening in Denmark, but also in Germany with different schemes. So with one-off compensations or buyout of the landowners. But we also discussed other economic instruments like carbon taxes, for example, which would put a burden on these lands, or also the underdeveloped carbon farming initiative with new schemes of kind of rewarding landowners, farmers for carbon, keeping the carbon in the ground, and new schemes will be developed at the moment. This is very interesting new developments on the EU level. Then we also discussed a little bit on Kaliningrad, actually, as we see at the moment in Kaliningrad and other parts of Western Russia, that there's quite a strong intensification of agriculture, actually, and also of the drainage. And at the moment, unfortunately, there's only chance for very niche implementation of peatland restoration, what we have seen in Kaliningrad, only on really leftover lands which are not really suitable for agriculture. And this is a big issue. And at the end, we also discussed a bit on what are actually the market forces for paludiculture. So how could we convince farmers, but also industries to get more into that, and we saw a little bit that energetic use is not really feasible. There are many dead ends there, which we see, but maybe there could be promising markets for material use, for construction materials, or similar. But here we have also the chicken egg situation. So what comes first the production of biomass, or first the demand from the industries? And this is actually one of the points we have to work with, and which is kind of the big challenge which we have to solve. That's from my side a little wrap up of our group.
Thank you very much. Are there any short comments on that? That's not the case, and then we will come to the Russian-speaking group. Who will report on that?
Yes, I will report on that.
Mm-hmm.
It was not that many people, but we have an interesting dialogue actually with Irina Popova, who is a manager from the WaterDrive project. And I have an impression that actually decision makers in Kaliningrad region seems to be in a very difficult situation, because two Interreg Baltic Sea project are lobbying at the same time opposite things. When we are trying to persuade that convinced that rewetting of peatlands is absolutely necessary and urgent, WaterDrive project is working on reconstruction of drainage systems. But the reason for this is actually that there are more than half of agricultural lands in Kaliningrad regions are in polder systems. The approach of the WaterDrive to reduce nutrients into the rivers and waters is to construct artificial wetlands next to the drainage systems, and yeah, probably also to use this water in the very dry season when it's necessary to bring water back to the agricultural fields. But there is one thing I think that was not taken into account by in this approach. Is quite okay, not obvious, but yeah, that's the polders are not working anymore without pumping stations, and their level of the ground is lower than the sea level, and somehow it is there is a belief that it was always like this. There is no recognition of the fact that there is this subsidence of this soil level of the peatland is disappearing. This shortly like this. Maybe Irina would like to add something, and I will translate it.
Yeah, can I say something?
Yes.
Marina, this was interesting to hear. I had yesterday a discussion, yeah, about connectivity. so actually it's one of the paradigms, yeah, that we restore the hydrological connectivity in our landscape. And now I learn more and more that it might even have advantages to make this connectivity, yeah. As you say, with this constructed wetlands, yeah, they, so to say, they interrupt, if you like, yeah, they interrupt a little bit the water flows, but this has, of course, the benefit, yeah, that the nutrient leaching, for example, will be reduced, yeah.
Yeah.
So I don't like if the things always become more complicated, yeah. So it was nice to have this connectivity, yeah, but it seems, and there are some other examples I don't want to discuss now, but this was interesting to hear, yeah. Thanks for
so
this.
that's the problem of the Water Framework Directive also, because they propose the connectivity up to the uppermost reaches of a river, and that's a problem for peatland rewetting. There we must disconnect, and there we must keep the water in. Yeah, it's only my short comment on that.
But I also think that so in the Kaliningrad situation, they have to be urgently interested in some polyculture development, actually, or if they're such a big share of the agricultural lands, sorry, are polders, are peatlands, and they, yeah, something should be done with this.
So on the other hand, that is a great chance to bring all these polders in polyculture. It's the easiest kind of peatland that can be brought into wet conditions, because you only must open the sluices and
Stop pumping.
And stop pumping. Yeah.
Pumping.
Any other comment? So
no, just maybe short remarks that the brilliant example of spontaneous restoration of peatland, what was Gromovo in Kaliningrad Oblast, when they stopped pumping. It's so easy.
Mm-hmm.
But I think that's also endangered that it will be brought back into drainage conditions later. So there's no security that Gromovo site will kept wet. Okay.
Maybe last one, yeah. This pumping, we discussed also this heavily, actually, yeah. And there was always the same, yeah. Stop pumping, yeah. So and you're right. There are also examples in Germany where the pump station was break down by himself, and then there was a nice rewetting, yeah. But we learned this high water tables can be also disadvantages. I'm not talking about necessarily methane emissions. But I was really thinking maybe, yeah, in some places it would be also an option to keep the pumping, yeah, to some extent at least, yeah, not to have a 60 or 80 centimeters deep lake, but only have a, I don't know, we know we have the spatial heterogeneity, but maybe we can or should manipulate somehow the water tables for some reasons. I don't know if this is really something we cannot discuss it to the end, but I think we should keep it in mind. Maybe that's a suggestion. Yeah.
Now, for paludiculture, we need water tables around soil surface a little bit higher, and in such degraded polders, after rewetting, there might be shallow lakes with 80 centimeters or 1 meter water depth, and with rather big methane emissions. To avoid that, so the pumping stations maybe must be kept working, but in the right direction. Yeah. Okay. So thank you very much.
There is a question.
Yeah,
Yeah,
front
please.
rising hand.
Yeah.
I just have a comment. I have been in the Netherlands, and maybe you not always have to take the extreme solution. In the Netherlands, they didn't want paludicultures because then they couldn't see the landscape. So they was working with higher the water levels and buying cows from Jersey cows, these small cows instead of the big cows. And these small cows, they was walking out in these areas with the water 20 centimeter under. So there is always a solution. So remember never to always to go into the extreme direction. Maybe there is a direction in the middle to have a solution. I think it was quite interesting to visit them and see they could not live without cows. That was quite interesting. Yeah, that was only a comment.
And if they would stop pumping at all, they would have water levels of 8 meters or something like that. So yeah, I think we now just come to an end. Are there any final statements that you would like to give? Jan, you wrapped up already a little bit. Are there any additional things you want to say?
Yeah, maybe I can just say some words because I was asked to make a little bit wrap up. I'm really amazed actually by the complexity and comprehensiveness of this discussion today, this meeting. We discussed, we started from water management points on measurements, modeling of hydrological complex issues, touched upon economics and policies. The mapping question was discussed. So it's really a very comprehensive set of questions which we discussed today. I felt also now in the final discussion that there's still a lot of challenges ahead and a lot of open questions regarding the mapping, regarding the hydrological modeling, but also about how to really design policies and how to work with these economic challenges which we are ahead, because it's a really complete transformation of peatland management. For centuries in Europe, we worked on draining peatlands, on making them suitable for cows and crops, and now we have to really in very few years, which are instrumental to really keep our targets, which we all agreed. All countries are members of or parties of the Paris Agreement. So all states actually agreed to fulfill. We drastically have to change, because 5% in the EU of emissions in most of the countries we are dealing with, this is even much higher percentage of total emissions coming from peatlands. You don't see them, you don't feel them, you don't smell them, but they are there. And we have to change, and yeah, that's why we are working on these challenges. And I would really like to thank all of you for your excellent contributions here, which I think from the two projects, Desire and WaterDrive, but also many other projects in this field, is really contributing to finding solutions, to making the right steps. We have to do them. We have to do them quickly. And as I'm always optimistic, especially after the vivid discussion today, I think we will make this. We will fulfill our goals. And yeah, with these words, I would like to thank all of you for participation today. And let's keep in touch. Let's not have this event today as a concluding point, but just more like an intermediate step of a lot of follow-up discussions.
Thank you very much. And Stefan, do you have some final comments from the WaterDrive project?
Yeah, some short comment. First of all, I would like to thank you all of super interesting workshop today, and I think I'm very glad about the decision we made, Wendelin, to crossbreed our projects in the way we have done today. So really interesting to join in. And for your information, there will be a workshop on private financing contribution to agro-environment investments on Monday in the same series. And on Tuesday, we will have the policy workshop. So you can check out the WaterDrive website and join in there. I understand from our discussion in our working group that the economic issues is of key concern, and how can you involve the private sector more into that. So thank you very much, Wendelin, and thank you all of you. Thank you.
Yeah, thank also all of you. And the best would have been to prepare the next Interact project so that we all pull at the common rope or something like that, we say in Germany, that we combine somehow the idea with end-of-pipe solutions, cleaning waters that have been made dirty in by agricultural use, by fertilization or by drainage of peatlands, and come back to the site-based solutions. That means solve the problems directly on that site where we produce them. And I think that would be a good topic for a common project that we should think about for future. So thank you very much for listening today, and I hope that you have our event in mind next time, and maybe that's also a basis for future cooperation. Thank you very much.